We are going to start the session. So guys, quickly share the session with all the other friends also, so that the maximum students will come and join this session. And here we are going to learn very important sessions. So guys, quickly share the session with all the other friends also, so that the maximum students will come and join this session. And here we are going to learn very important sessions. So guys, share the session with all the
Yes, sir. Let's start.
So let's start the session with the new topic, which is our gravitation. I said the gravitation and the Newton law of motion. These are the two topics that we are going to discuss today. And guys, there may be some little bit noise, and that will be clear in after 5 minutes. Actually, there is some plumbing work going on out nearby, so there may be some sound for a while. So just have patience if you are getting, if you are feeling some noise. Okay. So in the Newton law of motion, we have to discuss about frictions. Mainly in the last class, you have seen that there were a question from the friction in the previous year. So you should be able to cover the friction topic, and also you have to understand what are the different laws of the Newtons. So we will start with the Newton first law. So according to the Newton first law, just wait 1 second. Okay, so in the law of motion, we are going to discuss about the Newton's first law. So there are three laws of the motion, and first is based on the Galileo's law of inertia. Also, we called it. So, what is the other name of the Newton first law of motion? So we can say it as a Galileo law of inertia. So what is that? That is nothing but the force is the push or pull which changes or tends to change the state of rest or of uniform motion of the body. Okay, so you should be able to understand what is the first law of motion. The first law of motion says The everybody continues to be in the state of rest, okay, or of uniform motion in a straight line, unless the compelled by an external force to change its state. So the fundamental property of the body is that called is inertia. That when it always wants to be in rest, that is nothing but the inertia. So the force is the best we can understand. The force is the push or pull which changes or tends to change the state of rest or of uniform motion of body. So what are the different type of inertia? Inertia of rest, inertia of motion. It is the inability of a body to change by itself is state of rest. Okay, and inertia of motion means it is the instability of a body to change by itself its state of uniform motion. Like, for example, if I say about the inertia of rest, when we shake a branch of mango tree, the leaves or and the fruits fall down. Okay, so and suppose when a bus or train starts suddenly, the passenger sitting inside, the passenger sitting inside tends to fall back. So this is all because of the type of inertia, which is inertia of rest. Means it always wants to bring the body or the object to be in the state of rest. Now, inertia of motion, it is the inability of a body to change by itself its state of uniform motion. Suppose when a bus or train stops suddenly, a passenger sitting inside lean forward. A person jumping out of the running train may fall forward, like that. So, and the third type of the inertia is inertia of direction. It is inability of a body to change by itself, its direction of motion. So, like when a straight running car turns, sharply, the person sitting inside feel a force radially outward. Whenever the car turns in the, it has a sharp turn, then you may feel like it is going outside. You may feel like a force which will make you the outside, outward, readily outward. You can fall. So these are the type of inertia. Similarly, we have momentum. The momentum is nothing but the P is equal to mv that we have seen in the last class also, that the momentum, if suppose you want to calculate, that is nothing but the P is equal to mv. So that is your momentum. Now, what is the relation of momentum with the kinetic energy? That is also important. That is half mv square. Suppose we are doing, then mv is nothing but a, if I suppose multiply with m, so that is m square v square divided by m, and mv, the magnitude of the momentum. So 1 by 2 p square by m. That is also a kinetic energy. So kinetic energy is also given in terms of momentum. That is p square upon 2m. And if suppose you want to calculate the momentum in terms of kinetic energy, so you can write 2m into e. So that is another formula of momentum. So we have a two formula of momentum in terms of mass and velocity, in terms of kinetic energy. Now we come into the second law of motion. That the second law of motion says, second law of motion is nothing but the, suppose there is a force and that is proportional to the rate of change of momentum. So dp upon dt. There is the second law of motions. In terms of suppose if you want to say, the rate of change of momentum of a body is directly proportional to the unbalanced external force on it. So if an object of mass 1 kilogram has an acceleration of 1 meter per second square relative to the inertial reference frame, then the net force exerted on the object is 1 Newton. That is nothing but your second law. So, what are the different meaning? Like this also you apply F is equal to mass into acceleration. So, force is proportional to the dp by dt, and you can write F is equal to k into dp by dt. Okay, so the force is equal to k. K is some proportionality constant which is usually 1. Okay, and you can write the momentum as mv. So this is d by dt of mv. So this type of question is useful when you solve the questions of the rocket propulsion. That you in the Airport Authority of India, you can expect the question from the rocket propulsion because it is related to some what aerospace, right? So k into, if k is suppose not 1 right now, so this is dv upon dt, which you can write as a acceleration, and v is dm by dt. So dm by dt, when the mass is also changing with respect to time, that is nothing but a, in case of rocket, when there is a propulsion, the mass is also continuously reducing because of the combustion, okay, of the gas. This type of question. Okay. Now after this, um, we have the accelerated motion is the result of application of the force. There may be two type of accelerated force: when only the magnitude of the velocity of the body changes, and when only the direction of the body changes. So a basic type of questions it can be asked here. Suppose the force is given to you. Okay, like let me take one example. Let's say the force is given as a 6 I f and 8 j cap plus 10 k cap, and the acceleration is Parna के पास रहा हूँ. F is equal to m into a is equal to f upon m, and that is your force. Force magnitude is 6 square plus 8 square plus 10 square divided by 1. So it is nothing but your 200. So it can be written as 10 root 2 kg. The acceleration is 1. No? So you can write like this. This is mass and this is acceleration. So this, by this you can apply. Okay. Now coming to the second thing, suppose the external force is 0. If the mass is constant, then dm upon dt will be 0 here. If the mass is suppose constant for any particular system or body, then the dm upon dt will be 0. And if suppose constant, then this dv by dt is 0. So you can take one more example, here, if you take this one example. Suppose this is a block either that is present over here. Okay, that is the block. Now a block of mass 5 kg. Okay, this is the mass of 5 kg and is resting on a frictionless. This is the frictionless. Okay, so the friction is 0 here. It is stuck by a jet. Okay, it is struck by the jet. So here the water, we are continuously giving water to this. Okay, so it is struck by a jet releasing the water. So this is the jet which is releasing the water in this direction, and at a rate of 3 kg per second. So that jet is releasing the water at the rate of 3 kg per second. So at a speed of 4 meter per second. So the mass is also, mass velocity is constant, but the mass is changing because we are saying that 3 kg per second. So we have to calculate the initial acceleration of the block. Okay, we have to calculate the initial acceleration of the block. Okay, so what is that initial acceleration? So here you can see that the F is equal to d. mv into dmt by dt, and another is m into dv by dt. So the velocity is constant here, so that will be 0, and velocity is 4, and the mass is changing, so the force will be 12. And force is equal to mass into acceleration, and in which body we are giving the mass, so this is 5 into A, so A is equal to 12 by 5, so it is nothing but the 2.4 meter per second square. So that is the acceleration. So in this type of system where you have a body and you are giving a force into it to so that it can be accelerate, then you can calculate the acceleration by the Newton's second law. And now law of conservation of linear momentum can also be applied in this case. So what is the conservation of momentum? That is, the conservation of momentum says the momentum remains constant. Okay, conservation of momentum, that is nothing but a the external force, the force we said is directly proportional to the dp by dt. If the k is 1, then we can write the external force is equal to dp by dt. So suppose the force applied to the system, external force applied to the system is 0, then we said that there is a change of momentum is 0. So change of momentum is 0 means the momentum is constant. Change of momentum is 0, that means the momentum is constant, so that means the initial momentum is equal to the final momentum. Initial momentum is equal to the final momentum. So for a system of particles, this law can be extended in the different cases. So like for a system of particles, uh, okay, for a system of particles, if the net force or the vector sum of all the forces on a system of a particle is 0, then the sum of linear momentum of all the particle remains conserved. Okay, and force of center of mass of a system particle, when the force of the center of mass is 0, then the momentum of the center of mass is also constant. So this type of questions can be applied in the, like say that gun and the bullet, when you are suppose uh, trigger the gun and the bullet will be moving in the forward direction. So in that case, you can calculate the backward velocity, that is also known as the relative velocity, or you can say back velocity of a gun, because when you know that when you trigger it, that is known as the recoil speed or the kicks you can say. So when you trigger the gun, then the bullet move forward direction, but the gun moves in the backward direction. So when the gun moves in the backward direction, that is just because of the re, uh, this law of motion. That second law of motion we can apply, or third law of motion we can apply, and because of that we get the reaction force in the reaction force, that is known as recoil speed. Okay, so that recoil speed you can calculate. This is all based on the third law. So second law we said that F is equal to dp upon dt. Third law is nothing but the every action has the equal and opposite reaction. So here in this case we are learning the conservation of momentum. When the external force in any system is 0, then the change in momentum is 0. So momentum will be constant. Initial and the final momentum will be constant. Motion of the two masses are connected by spring, also we can apply the momentum case. The conservation of momentum can be applied. Rocket propulsion is also the case where the momentum can be applied. Conservation of momentum. And there is one more concept, that is the impulse. So So impulse, when you apply the force for a very short duration of time, then we call it as an impulse. Okay, if a large force acts on a body or a particle for a smaller time, then the impulse is generated. Impulse is nothing but the force. Impulse is equal to force into time. So suppose a force acts for a very short duration of time, then the impulse generated can be written as impulse is nothing but the force into time, that is F into integration from T1 to T2 is equal to F dt. Okay, so if the constant force acts on an interval delta t, then you can also say that this can sometimes also be written as F into delta time. When you know that, but for how much duration you are applying the force, then you can calculate. The application of this concept is the bogies of a train are provided with the buffers, and a cricket player draws his hands back while catching a ball. Similarly, a person jumping on hard cement floor receives more injuries than a person jumping on muddy or the sand road. The car, buses, trucks, bogies of the train, etc., are provided with a spring system. And suppose you can take this as, suppose you are throwing a ball into the wall and then it is coming back. There also you can apply the change in momentum. Like these conditions you can apply here. The change in momentum concept you can apply. So suppose we have a, when somebody has thrown the ball like this in the wall and it is going like this. Okay, so you have thrown the ball somewhere here, and this ball is having the mass m, and suppose this ball is moving in this side with the same mass. So you should know that the angle by which you throw the ball, that ball leaves from the wall in the same angle. So if suppose this is making an angle theta here, then it will make the same angle theta from this side also. So similarly, this angle will also be theta, and the velocity in this direction is v. So the momentum it will generate is p1 is equal to mv. But this momentum is having the two components, so that is mv cos theta, and this is nothing but in the downward direction it is having the mv sine theta. Similarly, here this is moving in this direction. So when you will extend it, so this momentum is nothing but P2 is equal to M into V, the same ball we are talking about. Okay, and in this direction it is going like this is theta. So this is also theta. So this is MV cos theta, and now it is MV sine theta. So this mv sine theta is having the same direction. So when you calculate the change in momentum in the y direction, so change in momentum in the y direction is mv sine theta in the downward direction, means final momentum. This is your final momentum in the y direction minus initial momentum in the y direction, that is mv sine theta. So there is a change in momentum in the y direction which is 0. But the change in momentum in the x direction, this x direction we suppose take the positive momentum, this one, and this is the negative sine theta. Uh, yeah. Okay. Wait. This is sine theta actually. Okay. So mv cos theta. This is mv cos theta, and here this is in this direction. So if you take this direction as positive, then this direction will be negative. So minus of minus mv cos theta, and now you have the 2 mv cos theta. So change in momentum in the direction of x will be 2 mv cos theta, and change in the direction of y will be 0. So in this type of question, if suppose the mass is given for the ball and they are asked to calculate what is the change in momentum of the ball, then change in momentum of the ball is directly you can write 2 mv sine 2 mv cos theta. Okay, so that was the example. Now you can also calculate the free body diagram questions where there are two bodies which are connected by the force. Okay, so in that cases, how do you calculate? So there are contact force, contact force arises when one body is in physical contact with the another. The force exerted by the ropes or the strings, the force involved in the collisions, the force of the friction between the two surface, and the force exerted by the fluid on any container. So these are the different cases. So we will learn that by some examples. Suppose there are two blocks. Okay, suppose there are two blocks like this. Okay, there are two blocks. This is suppose the block M, and this is suppose the block capital M, and we have applied the force from this side, and they are placed on some surface like this. This is the horizontal surface. Right now we are not talking about the friction, so this is the frictionless surface. Okay, so let us say this mass is, suppose you can take it as a 2 kg and this is as a 5 kg. So M and M is given, and the force we are applying is say 35 Newton. 35 Newton is force. So find the force between the blocks. So you have to find the force between the blocks. They are connected by the string. So they are connected by the string. You have to calculate the force between them. So first of all, to calculate the force, we can calculate its free body diagram because this is connected by the string. So there will be a tension force in the string. So this is T, this is T. These are the tension force. So these tension forces are known as the internal forces. They always occur in the pair. So in this question, what we want to find is we want to find this force between the two bodies, that is nothing but the tension. So we have to calculate, find the tension in the string. Okay, this is one example I'm taking. Then we are also going to solve some objective questions which were asked in the previous year. So find the tension in the string we want to calculate. So first of all, to calculate the acceleration, because you are applying the force, so you are applying the force in this direction, so it will be showing you the acceleration in this direction. The body will move in this direction, and because they are connected by the same string, so the acceleration will also be same for both the body. Because they are connected by the same string, the acceleration will also be same for both the bodies. Now when you apply this force, acceleration will be same. So we will apply the net force which is applied on the system is equal to mass into acceleration. That is total mass. Okay, that is the mass which is total mass into acceleration. So acceleration is nothing but the net force divided by total mass. Okay, that you can write it as total mass. So what is the net force applied? It is 35 only. What is the total mass? The mass is m plus m, which is 5 plus 2. Okay. So that is the total mass, 2 plus 5, right? So it is going to give you the 5 meter per second square acceleration. Now, once you calculate the acceleration, you can draw the free body diagram for any of these two bodies. So let us suppose I am drawing the free body diagram for the mass m. That is, now I am representing this mass by the point mass. And in this mass, the force which is applied is tension force in this direction. And there is a force which is applied in this direction, sorry, in this direction again, that is F. And body is also accelerating in this direction. So you have to always take the force greater in the direction of acceleration. So because the acceleration is in this direction, so the force T will be taken as greatest force. So that is how do you calculate this uh, tension force. So you can say T minus F, because this force is also applied in this direction. So you can say the T plus F. Okay, this T and this F is also in this direction. So T plus F equal to mass into acceleration. So we want to calculate T. So mass into acceleration minus F. So mass, okay, mass is how much? 2. Acceleration is 5. And F is how much? 35. So we are getting 25. Why we are getting negative sign? Because we assume that the force is in this direction. Minus 25 Newton we are getting. So we are assuming that the tension is in this direction, but because you are applying the force here, so there is an equal and opposite reaction. So in this M, there will be a reaction force because you are applying the force to the M in this direction. So this M will apply the force on this direction. So the actually the tension direction of the tension will not be in this direction, that will be in the reverse direction. So that is why you are getting the negative sign. That is the reason. Okay, but the value, that is the magnitude, is correct. 25 Newton you are going to get. Okay, is it clear? So this is one kind of example that can be asked. And if I take one more example, suppose related to some pulley related problems, or you can say rope related problem also we can solve, pulley and rope. Let me take one example. Then we will discuss about the friction also, because the friction question was asked in the previous year. So we will discuss the friction questions also. Suppose we will take one more questions related to this. If suppose there is a force applied in this direction, so you are applying the force in this direction, then how do you calculate? Okay, you are applying the 50 Newton force in this direction, which is making an angle 60 degree. The mass is 5 kg. This is also frictionless. We have to find the acceleration. So because you are applying the force, so it will move in which direction? How do you calculate the acceleration? So obviously the acceleration will be in this direction. So we have to consider the component of the force, because the force is applied in some angle. So this angle we will calculate the 60, and this will also be 60. So this is your F cos 60. So the force in the force has the cos component, and the force is also having the sine component. That force, which is the cos component, is applied in the negative direction, and it is the downward direction. So it will not be responsible for the acceleration, because this force is having the two component, and the sine component is giving the force to the body in the forward direction. So it will accelerate. So the acceleration is equal to force upon mass from the previous this formula. So force is equal to mass into acceleration. From here, the force applied is now F sine 60, because it is the force which is responsible for the forward movement of the body. So that is 5. Now the force applied is 50, and sine 60, which is root 3 by 2 divided by 50. So it is 10 root 3 by 2, or you can say the 5 root 3 meter per second square. So this you can apply. If the suppose it and particular angle you are applying the force, then this can be applied. Now you can take one more example related to the conservation, or you can say the second law. The question is, suppose I am taking one question, that a satellite I am taking, a satellite in a force-free space where force is not applied, in a force-free space, that is the external force is 0. Okay, this shows that external force is 0. So a satellite in a force-free space, when there is no force or external force is zero, has the external force is zero, I get it, sweeps stationary interplanetary motion. Okay, interplanetary dust at a rate of dm upon dt equal to alpha into v. Then what is the acceleration? What is the acceleration of satellite? Let me take one options also. Minus 2 alpha v square by m. The second option is minus alpha v square by m. Third option is minus alpha square upon 2m. And the fourth option is minus alpha into v square. So these are the four options. A satellite in force-free space sweeps stationary planetary dust. Then how can you calculate? So that as I told you that when there is a rocket or satellite type of questions comes and there is a change in the mass, that is the rate of change in mass is there, then you can apply that second law of motion by which we said that the external force is zero, then there is a momentum conservation will be applied. So momentum is conserved, that is dp upon dt will be zero. So here you will write m dv by dt plus v dm upon dt equal to 0. So dv upon dt is acceleration, so mass into acceleration, plus v into dm upon dt is alpha into v equal to 0. So acceleration is a minus alpha v square upon m. So minus alpha v square by m, second option would be the correct one. Okay, so this type of questions where you will see the change in motion, the change in mass, you can apply. Is it clear? Okay, good. Now, coming to the next question, suppose there are two blocks and they are connected by some pulley. So suppose there is a pulley, okay, and it is hanged by this particular pulley, which is frictionless. We have to calculate the acceleration of the system. Okay, this is the two different bodies A and B. You have to calculate the tension in the string. This tension you can calculate tension in the string and also find the acceleration. Find tension and the acceleration of the system. Find the tension in the string and acceleration of the system. What are the value of the masses? Let me take it as a 7 kg. And this is nothing but a 3 kg. Okay, and you can take the G as a 10. So how do you find? Let me give you options for acceleration. Option for acceleration is 100 and 3 and 300 or 30 and D is 10. Acceleration. These are the acceleration, meter per second square. So as you can see that when there is a body hang on this pulley, this mass will feel a force in the downward direction because of gravity, which is mass into G. That is the 3 into G force is in the downward direction. Okay. So in this 7 kg, there is no force other than this T. So this tension force are internal force. So tension forces are internal force that always occur in the pair. The tension forces are internal force. Okay, so that always occur in the pair. So that's why we can take this as completely zero. So we don't take these internal forces while calculating the acceleration. So to calculate the acceleration, we said that we will take the net force divided by total mass. So we will not take the forces of tension. That is internal forces we will not consider. So in this system, only one force is applied, which is 3g. The total mass is 10. The g is also 10. So acceleration is 3. G is 10 and this 10 will get cancelled. So we will get acceleration as a 3. Now to calculate the tension, you can apply the free body diagram. This free body diagram for the 3 kg mass. This body is accelerating in the downward direction because it is hanged. So this will try to pull it. So the system will accelerate in this direction. The A block will move in the right side. The B block will go in the downward direction. So this acceleration is in the downward direction. There is a force of tension in the opposite direction, and there is a force due to gravity. This is mg or 3g. So how do you calculate this t? So this t, because the system is accelerating in the downward direction, so we will take this 3g minus t equation. How do you write the equation? 3g minus t is equal to mass into acceleration. Mass is 3 kg and acceleration is a. So now t is equal to 3g minus 3a, that is 30 minus 3 into 3, that is 9, so 21 Newton. So this 21 Newton force is felt by this particular string. This string will have the force of 21 Newton. Any doubt in this? Now we can take one more example in this. That is nothing but suppose we have a platform like this and there is a mass of 6 kg and these are the two pulleys. So these are the two pulleys and here these are the strings that is passing over these pulleys and there are two blocks connected over here. So now we will be able to calculate this 6 kg block is there and we have to find the acceleration by which the system is moving. So this is 1 kg block, okay, and this is 3 kg block. You have to find the acceleration. What will you do? And both the pulleys are frictionless, the surface are frictionless. So here you can see when the 3 kg block is more, so the whole system will accelerate in this direction. So acceleration in this direction, it will move in the right hand side, it will move in the upward direction. So again, there is a tension force here, T1, because these two are in the different string. This is different, this is the different. So we will take the internal forces, the tension forces as T1, T2. Now, to all these internal forces are not considered, I told you. So to calculate the acceleration, this is the force which is applied in this 3G and the force which is applied that is on the 1 kg, the force because of the gravitational gravity of the earth will try to pull this body in the downward direction. So the total force is 3g, which is in this direction, minus g divided by total mass is 10. So this is 2g upon 10. G and 10 will get cancelled. So acceleration is 2 meter per second square. So this is how you can calculate the acceleration of such system. So to calculate the acceleration, you don't need to calculate any other internal forces. You can directly consider the external forces which is applied to the system and by which you can calculate the acceleration. Okay. Suppose you want to solve one more problem related to this. Suppose this is the one body of 5 kg and it is all there is one more body of 3 kg. Okay, this is 5 kg and suppose this is 3 kg. Two masses of 5 kg and 3 kg are suspended with the help of a massless inextensible string and the whole system is moving upward. Okay, the whole system is moving upward with the acceleration of 2 meter per second square, let us say. So what is the tension T1 and T2? So this is the tension T1 and this is the tension T2. How do you calculate this tension T1 and T2? Let me give you the option 96 and 36, 36 and 96. Both are 96 or both are 36. These are the four options. So as it is already given that it is accelerating in the upward direction, if I draw the free body diagram for the 5 kg, okay, so I will take this because this is also accelerating in the forward direction. So it is 5 kg and the tension force is in the upward direction. There is a one force in the downward direction. Okay, and there is one more force T2. So we will take this T1 minus T2. Okay, this is T1 minus T2 minus this is the 5g in the downward direction minus 5g is equal to mass into acceleration 5 into a. This is first equation we will get. And for the 3 kg block, if I draw the free body diagram, 3g the force in the downward direction, the tension force, because when the body moves in the downward direction, this tension force will try to pull it because of the stationary. It always wants to be in a stationary condition. So the force will be in the opposite direction, that is the force T2, and the system is accelerating A in the upward direction, and this is 3 kg. The body is 3 kg. So because the system is moving in the upward direction, so this is T2 minus 3g equal to 3a. So T2 equal to 3a plus 3g. Acceleration is also given, so this is 3 into 2, 6. And 3 into 10, g is 10, so this is 36 newton force. 36 newton is T2. So these two options are eliminated now, B and C, because this is 36 we have already got. Now what is T1? So T1 is equal to T2 plus 5g plus 5a. So obviously all are added together, so we are going to get 96 only. 5 into 10 plus 5 into 2. So 10, 50 plus 36. 60 plus 36 is 96. So 96. How much it is? 96. So 96 Newton and 36 Newton we will get. Okay, now one more example you can take. This is force and the time graph. Force and the time graph is given. So this is 0, this is 2, this is 4, and this is 8. Okay, so the maximum height is suppose 6, and this height is 3, and this height is minus 3. Now you have to calculate the change in momentum. What is the change in momentum? Okay, what is the change in momentum? Options are 24 Newton second, and let us say 20 Newton second, 12 Newton second, and 6 Newton second. So these are the four options. So there is one concept that we learned about the impulse. Okay, and the impulse, we said that it is nothing but the integration from T1 to T2 F into D2. That means nothing but the area under FT graph. Okay, area under force and time graph. So area under force time graph, and this is nothing but the impulse is also called as change in momentum. Impulse is nothing but a change in momentum. So that means the impulse is equal to change in momentum. So the change in momentum is equal to area under the force and time graph. So what is the area? So let's calculate the area. Area is 1 by 2, base is 2, height is 6, plus or minus, because now this area we are calculating. So this area will be negative, this area will be positive, and this area will also be positive. So this is minus width into height. So width is 2 and the height is 3. So this height we have taken 3 and the width is 2, and the negative sign because it is coming in the downside, in the below the x-axis, plus, and this is 2 into 3. So this 2 will get cancelled. So we are getting 6 now. Okay. No, it is not cancelled because this width is not 2, this width is 4. So this is 3 into 4. 3 into 4. So 3 into 4 is 12. So it is 6 minus 6. Actually, these two are cancelled. So the answer is 12. So answer would be 12. Okay. So this is the formula which you should know about the impulse. Now let's take one example related to the friction. Okay, we will solve now some questions of the friction, because um, we have to solve some previous year questions also which is related to the friction. So you should be able to solve the question based on friction. First law we have seen, second law we have seen, third law we have seen. Now we will discuss about the questions based on the friction. Now suppose there is a block. Yeah, so I should take this as an example. Simple question, actually. I was thinking of one simple question. So 100 Newton force acts on a, sorry, this is the 10 kg block, acts on a 100 Newton force acts on a block of 10 kg. So suppose we have applied a force of 100 Newton to this block. Okay, the coefficient of friction between this surface and the body, the coefficient of friction between the surface and the body is 0.5. what is the acceleration of the block? What is the acceleration of the block in this case? You have to find the acceleration. Okay, your options are, let us say, 2.5, 5, 10, and 7.5. You have to find this acceleration. So now this is force, the friction also there. So if you suppose don't know about the friction, then what you would have done, acceleration is nothing but the force divided by mass. Force is 100, the mass is 10, then it is 10. So you would have said as option as third, right? But here I told you that there is a friction between the surface and the block. So when you apply the 100 Newton force on this block, the friction will try to oppose it. Friction will try to, the block will try to move in the right side because the force is applied here in the right side, but the friction force always works in the direction opposite to the motion. So the when blocks tries to move, this will be the friction force, that is known as limiting friction, is start working opposite direction to the motion. So if the friction force is applied here, what is the friction force? How do you calculate the friction force? So the friction force is, which is equal to mu into n. Okay, mu into n. And what is n? N is the normal reaction force. So this is the mass. So there is a 10g force in the downward direction because of the gravity of Earth. So when the block will apply the force, when the block will apply the force on the surface will also give the reaction force, that is known as normal reaction. Okay, so what is the n? That is nothing but the mg. Okay, m into g. So mu mg. So now how do you calculate the acceleration? Acceleration is the total force applied on this block is 100 Newton in the right hand side, and the friction force in the left hand side divided by net mass. Mass is 10. So 100 minus the limiting force mu is 0.5, mass is 10, g is also 10. So it is 50. Okay, this is 50. So 100 minus 50 divided by 10. So it is coming as 5 meter per second square. So the answer is 5 meter per second. Okay, suppose there is no friction, then the answer would have been 10. But because of the friction, the acceleration is less because it will always try to oppose the motion of the block. Okay, so this is the condition when the force is applied and the block is moving in the forward direction. Suppose if this limiting friction force is more than the 100 Newton, then even if you apply the force in the forward direction, the block will not move in its from its plates. Okay, the block will not move from its place if the limiting force, that is the friction force, is greater than the applied force. So block will not move if applied force is less than the limiting force. So this is suppose the block A and this is suppose the block B. Then the block A is of 10 kg and the block B is of let us say block B we want to calculate. The mass of the block B we want to calculate. Okay, and it is given that the horizontal surface is having the friction with this 0.2. So what is the minimum the question is minimum mass of B to start the motion. Option A is 2 kg. Option B is 0.2 kg. Option C is 5 kg. And option D is suppose 10 kg. What should be the minimum mass to start the motion? When the block will move, suppose, so we will assume that the block is moving. Okay, we will work as a block is moving. So if the block will move, obviously the block will move in this direction. It cannot go in the forward direction because we are not applying the force here. Na? So there is a force in the vertical direction which will be mg. So m mass of b into g, the force is applied here because of the gravity of the earth. So it will try to pull this block, and when it is pull this block, then this block will also start moving. So how do you calculate the net acceleration? The net acceleration is the force. What is the force applied? This is the mb into g in this direction. And because when there is a friction, so when the block tries to move in the right side, there is a friction force in the left hand side. So there is a friction force. So mb into g and fl limiting force divided by net mass. So ma plus mb. So mb into g minus limiting force. What is the limiting force? Limiting force is mu n. So that is mu into n. N is ma into g. Okay, mu n. So this mu mg I have applied, na? Mu mg divided by net mass, ma plus mb. So mb, what is the mass of b? We don't know. Yes. Now how do you calculate? So because this block should just start moving, na? It just start moving. So if suppose it does not move, then what should be the mass of the block? So we want to find the condition when it just starts the moving. So we will assume that suppose the block is not moving. So if they're not moving, that means the acceleration is zero. So if it is acceleration is zero, then mb into g minus mu into ma into g divided by ma plus mb equal to zero. So if this is not moving, then the mb will be mu into ma. So mu is 0.2 and a is 10, so it is 2. So 2 kg will be the minimum mass when the block will just start moving, means just above the 2.00001. Just above the 2.00001 kg, the block will start moving in the downward direction. So 2 kg, we can say that the minimum mass for which the block will just start moving, or it will be just stationary condition, you can say. And if you will increase the just very, very small mass, then the 2, then you will get the motion, that is the acceleration. Okay, so we will discuss now the gravitation part. Okay, so the gravitation part we will discuss. So these are the few questions related to the friction. I will discuss more questions if we get the time here. Let's discuss the gravitation part. With the gravitation is quite easy because there are Kepler's law of motion that you have to understand. Kepler's law of planetary motion. Then it will be almost potential that you should understand, and you have to find the uh, how much distance it has to be moved, so that escape velocity it will cause the gravity, earth gravity, right? So these are the things that you should learn in the gravitation. So we will start discussing the gravitation, and we will discuss some questions related to that. So can you comment in the comment section that are you with me right now? Any doubt in this? So Kepler's law of planetary motion. Okay, so law of gravitation, universal law of gravitation, that there are two bodies, then they will always try to attract each other. and acceleration due to gravity of Earth. And variation in the acceleration due to gravity and gravitational and the inertial masses, intensity of gravitational field like electric field intensity, then the potential energies. So these are the different things that we need to discuss here. So according to the new Kepler's first law, the all the planets in revolve in an elliptical orbit. Okay, the first law says all the planet revolve in the elliptical orbit around the sun. Okay, so important thing is that it revolves around the sun in an elliptical orbit. And the second law is the law of area. We call it as a law of area. So law of area says that aerial velocity, aerial velocity is always equal to aerial velocity is constant. That means it will it will sweep the equal amount of area in the equal interval of time. Means you can say that dA upon dt is equal to constant. That suppose a planet is there and it is revolving in the elliptical orbit like this. Suppose this is an elliptical orbit. Okay, suppose there is a sun and a uh, planet is revolving around this sun. So this suppose the planet covers this much area. Okay, and then when it will move in this direction here, so this much area. So the area it will cover here, whatever time, let us say the time t1, then the and in the time t2 it will cover the same amount of area. So that means I can say that a1 upon t1 is equal to a2 upon t2. That is known as the second law of Kepler's, that is the law of area, that it covers the same amount of area in the time. So when it will be in the near to the planet, its speed will be faster. So when speed is faster, it covers the number of distance, large distance. And when it moves very slow, when the satellite will move far away from the sun, then its speed is low, and because its speed is low, it covers the less region. But because the distance is far, so the area is same for both the case. And obviously, the third law is related to the law of time period, which is t square is directly proportional to r square. The square of period of revolution, the square of period of revolution is directly proportional to the semi-major axis of the orbit. A cube also you can write. So there is one more thing that comes in the ellipse, that is the eccentricity, which is a minus b upon a plus b. A is the semi-major axis, this is A, and this is B. The semi-minor axis is B. So like a force, Coulomb force, we have seen that F is equal to K Q1 Q2 upon R square. Similarly, we have the universal law of gravitation, by which the force is equal to G into M1 M2. There are two masses, suppose M1 and M2, and there is a distance between the two masses are R, then the gravitational constant is G and M1 M2 upon R square. What is the value of G? So the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square divided by kg square. Yes. Okay, what is the acceleration due to gravity? Acceleration due to gravity, because this is F is equal to mg and the force is also equal to G into m1 m2 upon r square. So this m and m will get cancelled. This is suppose mass m1. Then in that case the G is nothing but the gm upon r square. Gm2 upon r square. That is the acceleration due to gravity. If a point mass is situated at the surface of the earth, okay, a point mass m, that we have taken this m1, suppose this is earth, okay, suppose this is earth, it has the radius r, the point mass is situated here of unit mass, and the mass of the earth is capital M, the mass of the earth is capital M. So let me write in this way, let me write it again. The mass of the earth is capital ME, the radius is RE, that is earth. So G, that how much gravity, by which gravity the earth actually pulls the body. So when the body is placed on the surface of the earth, then the earth tries to pull it by the force, that is ME into M, that is the force of attraction, that is universal law of Newton's universal law. So G M E M upon RE square. And what is the force act on a body? That is the M into G also. So M into M, so G is equal to G into ME upon RE square. So when you put the mass of the earth, and you put the value of G, and when you put the value of R, you will get the value as 9.8. Suppose this is the earth. Okay, this is the earth, and we are having uh, a point P somewhere here, which is at distance r from the surface, and the capital R is the distance of the radius of the earth, and this is a small r, and which is completely the height h. Let me write this as a h, not r. The height is h. Now, suppose I want to calculate the acceleration due to gravity, that is G, acceleration, that is G, acceleration due to gravity, that is G, where the first is height above the earth surface, height above the earth surface. When it is height above the earth surface, so how do you calculate it? Because this G is equal to G into ME upon RE square that we have seen. Now you are changing the height. The height is now G into ME is there, but the height is now RE plus H, that the radius of earth, plus H whole square. So when we divide both equations, suppose G dash, or you can put the value of G dash, this is G into RE square, And if I take the RE common, then G RE square divided by RE square 1 plus H upon RE whole square. So this RE square will get cancelled because the radius of the earth is far large, much very large than the height above which we want to calculate. So if the RE is very high, then H. Okay, this is the one formula that we have got. But now if we apply this condition, then it can be approximated to G into in bracket 1 minus 2H upon RE. So above the earth surface, if the distance is significant, not significant, in fact the height is not very large than with respect to the earth surface, earth radius, then we can approximate to calculate the gravitational due to acceleration due to gravity. And similarly, in the second case, if I take, if suppose I want to calculate just below the earth surface, okay, below the earth surface at any height d, below the earth surface at any height d, suppose this height I want to calculate below the earth surface at any height d, then how do you calculate depth? We generally call it as depth, d for depth below the earth surface. Here we want to calculate the acceleration. Then this is g is equal to g into me upon re square, and g dash will be now re minus d, gme upon re cube and re minus d. Okay. So now the value will be g dash is equal to g 1 minus d upon re. G dash is equal to g 1 minus d upon re. So thus the value of g decreases by a factor 1 minus d upon re as we go down below the earth surface. So at the earth surface, the gravity will be g, which is 9.8. As you move above, it will be 1 minus 2h upon re. So here also the g will be decreasing as you increase the height, or you go down, then also the g will be decreasing by the factor 1 minus d upon re. Now you can also calculate the intensity of gravitational field. Intensity of gravitational field, that is the like electric field intensity. Similarly, you can calculate the intensity of the gravitational field with respect to the distance. It is in this, as you move in towards the earth surface, it starts decreasing linearly, and when the r is equal to r, it is directly proportional to r, and then it is increasing. So the value is electric field due to the gravitational field, or intensity due to the gravitational field, not electric field. So G into me upon re square. G into me with minus sign. Let me write not in re. It is r square into r cap. Kq by r square. Similarly, minus gm upon r square in the direction of r. Now, how do you calculate the gravitational potential for a solid sphere like Earth? So, gravitational potential. Okay, when the you are calculating the r greater than r, then it is minus gm upon r. When you exactly come on the surface of the earth, then the gravitational potential is minus gm upon capital R. And when you try to calculate the potential inside the R, then it is gm minus gm in bracket 3r square minus r square divided by 2r cube. This is the formula. So these are the three formulas that you should know about the gravitational potential. So at which point you want to calculate the gravitational potential, according to that you can calculate and you can apply the formula. Similarly, in this further the discussion, when we move the discussion of to the gravitational energy, okay, gravitational potential energy is, suppose we are denoted by UG. The potential energy is nothing but like a work done. So you have to multiply with the mass only. So G into ME, that is the mass of Earth. Now, because of this system you are moving, so actually the work done against the field we are doing in bringing a body from infinity to a point of gravitational field is called the gravitational potential energy. Means we are bringing a body of mass m from infinity to the field of gravitation. Then we have to do the work because we are moving against the field. So against the gravitational field. So that is nothing but the mass into the potential. The potential was gm upon r. So gme upon r, that r, and we have to multiply which mass we are bringing, m. If we bring up to greater than r, if we bring the r is greater than means above the earth surface. When it is below the earth surface, so from infinity to inside the earth surface, when you bring, so it is 2re cube. This is gm 2re cube, and then the same thing 3r square minus r square. That is the radius of earth. Now if r is less than re. Okay, the same thing. See here, there is only one difference, that you have to multiply with the mass. When you calculate the in the electric field, how do you calculate the work done? In the electric field, how do you calculate the work done? In the electrostats. Okay, so how do you calculate the work done? Is nothing but the potential difference, and work done is nothing but potential difference. Potential difference is nothing but work done is nothing but you can say the charge into potential difference. Like, let me say more appropriately, in the electrostats, in the electrostatic, the potential difference, how do you define the potential difference? The potential difference is work done per unit charge. Okay, work done per unit charge. So work done is charge into potential difference. So what is the charge? Here the charge is replaced by mass, and the potential difference is gravitational potential. So gravitational potential into mass, gravitational potential into mass. So this is the mass, and this is gm upon r is the gravitational potential. So mass into gravitational potential is gravitational potential energy, because whatever work whatever work we do, it stores in the system in the form of potential energy. So that is the electrostatic potential difference. But yeah, it is, you can correlate it. It is electrostatics is correlating to your gravitation. Now, how do you calculate the escape velocity? What is the escape velocity? This is the minimum velocity by which we should project any body, and then it will cross the field due to Earth. Okay, minimum speed that should be given to any body to escape away from the gravitational field of Earth or any other planet. So, escape velocity is root over 2 gm upon r. That is the formula. 2 gm upon r. Or you can also write it as root over 2gr. Okay, because we have seen that the g is equal to gm upon r square. So when you put the gm is equal to gr square, then it is 2gr. Now for Earth, this R is also constant, which is 6400 kilometer. G is also 9.8 meter per second. Then you calculate escape velocity, it will be 11.2 kilometer per second for Earth. For Earth, the escape velocity will be 11.2 kilometer per second. So the minimum energy needed to escape a body from the surface of the planet is gmm upon R. So what is geostationary satellite? So geostationary satellite, when the satellite is placed above the Earth's surface at the height of 36,000, then it is called a geostationary satellite. Okay. So like if you suppose want to solve any questions related to the related to the Kepler second law, suppose, then we can solve it. Suppose this is one question that I am taking. Okay, let us say that a planet moving around sun sweeps area A1 in 2 days and let us say A2 in 3 days and A3 in 6 days. Okay, then the relation between A1 and A2 and A3, A1, A2 and A3, you have to find the relation. Okay, so this is the sun and it is supposed covering this area as A1 and this area as A2 and this area as A3. Your options are 3A1 equal to 2A2 equal to A3, and you can take 2A1 equal to 3A2 and 3 into 2 is 6A3 and 3A1 2A2 and 6A3 and 6A1 3A2 and 2A3. Yeah. Okay, so the question is a planet is moving around the sun, sweeps area A1. A1 area it is covering in the 6 days, 2 days, A2 area in the 3 days, and A3 area in the 6 days. Then what is the relation between A1, A2, and A3? So the relation between A1, A2, and A3 are okay. So the as we know that from the aerial velocity, this dA upon dt is constant. The aerial velocity is constant. Okay, from the Kepler's second law. So the A1 upon time T1 is equal to A2 upon time T2 is equal to A3 upon time T3. So how much area it is covering? A1. T1 how much time? 2. A2 is 3 and A3 area covers in 6. So when we take that multiply with the 6, suppose, so we will get the 3A1 and 2A2 and equal to A3. You have to do it. Yes. So answer is option A. Okay. So this type of questions can also be asked in the gravitational. So, guys, we have covered the two topics again here today, gravitation and your Newton law of motion. Now, in the next lecture, which will be held maybe tomorrow, we will be discussing about the magnetostatics, that is the moving charges we will be discussing. Okay, moving charges and magnetism. We will discuss the moving charges and the magnetism tomorrow. Okay, at the same time, 5 p.m. Suppose, guys, you have any information, if you want any information from IGC, then you can call in this number for getting the update about the upcoming batch. If you are preparing for any exam, like suppose gate, you are preparing for gate 2025, and if you want to inquire, then you just call in this number, and these are our website. So thank you for watching this session, and don't forget to subscribe this channel and join our other social media platform where you will get the link of the upcoming sessions, and that will be helpful in your preparation. Thank you.